Hey everyone, it's Mr. Canfield. Make sure you have your calculator. We're doing Chapter 8 test review in geometry. And make sure you have something to write with Mr. Canfield. That would be beneficial. What color should we pick? Let's go for, we'll go for the peach color. All right. So I'm gonna go through and explain everything as best I can. Here we go. First question says, what is BC? Besides my initials. So BC is right here, so we can put an X there. And so we've learned a bunch of different strategies figuring out missing pieces of triangles this chapter. And when we know two of the sides of a right triangle, finding the third side, we can use the Pythagorean Theorem, which is a squared plus b squared equals c squared. So just a reminder on that formula, A and B are interchangeable, but C is not. C is always nailed down. It's always the hypotenuse. And the hypotenuse is the one that's across the street from the right angle. So 37 is our hypotenuse. So that tells me 37 squared goes over here. On this side, it doesn't matter which one's A and which one's B. So 12 could be A or B. X could be the other one. Doesn't matter. So I'll say 12 squared plus X squared is equal to 37 squared. So now I need to find out what each of those numbers are. So 12 squared, 37 squared. I got 144 and 1369. So I'm just filling those in where they belong. And remember, when it says this plus X squared is equal to 1369, X squared isn't by itself yet. So I need to get it by itself, and I'll do that by subtracting the 144. So I'll do 1369 minus 144, I get 1225. That's not X, that's X squared. So X squared is 1225. So to finish it up, we'll just take the square root and be done. Square root of 1225, and we get that X is 35. All right. So that's our first question. In our second question, do line segments with the given lengths form a right triangle? This is really just saying, hey, if the Pythagorean theorem works, we know it's a right triangle. If the Pythagorean theorem doesn't work, it's not a right triangle. So let's see, if I take 36 squared and I add that to 77 squared, I get 7225. What happens if I square 85? I get the same number. That tells me a squared plus b squared equals c squared. And that's only true in right triangles. So since those added up to the same thing as the other side, yes. Should I color it in more? Is it colored in enough? All right, so yes, we're good. What if we look at our next one? So 14, 14, 14 root 2. So I added this one in kind of as a check to see if you know the special right triangles. This is one of our special rights. When we have the first side and the second side are the same, and the third side is the same, just also multiplied by root 2. That was our 45, 45, 90 triangle. So yes, this also is one. And then our third one here, 4, 4 root 3, and 8. This was the 30, 60, 90 triangle, where the shortest and longest are doubles of each other. One's the double of the other. And then the middle side is the original leg with root 3 tacked on the end. So this also is, so out of all the times we've done these, I think this is the first time that all three are yes. So that's all that's happening there. All right, 3. The hypotenuse of a 30, 60, 90 triangle has a length of 15 centimeters. So that's actually what we were just talking about here. So it's 4, 4 root 3, and 8. So the longest is the hypotenuse. So that's gonna be 15 there. So if I'm trying to find the other two sides, well, I can follow this same relationship, right? To get from 8 to 4, we cut it in half. So to cut 15 in half, because this says it's the hypotenuse, it's the long side. To cut that in half, well, 15 divided by 2, right? 7.5. And then the middle side is that first side, so 7.5 with the square root of 3 written on the end of it. That's it. That's all we do. It's that same pattern, but here. And if you're like, Canfield, we did like a whole quiz on this. Yeah, I know. A test looks at stuff you've been quizzed on, looks at other things too. All right. 4, which is the area of the rectangle? So we've definitely done a problem like this together before. So I'll kind of remind you how we walk through it. So to find the area, you do length times width. Either one of these can be the length, either one of these can be the width. Doesn't really matter however you think about it. But the problem is this side right here gets cut and we don't know this. But I could find that, right? I could say 87 squared plus x squared equals 145 squared. Pardon me. So let me explain how I knew that. So this is a rectangle. That means this is a right angle here. So then if I kind of ignore all of this, I just have a little triangle down there. So now I can do the Pythagorean Theorem, and this looks just like question number 1. So, and the shortcut that a lot of people will do, like on number 1, you notice that we squared this, we squared that, and we subtracted them from each other to get it when it was on this side. So a lot of people will actually just jump to that, and they'll do 145 squared minus 87 squared, and you can even do that 145 squared minus 87 squared. So almost says 1, 2, 3, 4, 5, 6. That's cute. And then we'll take the square root of it. Oh, I can't push up on this calculator. 1, 3, 4, 5, 6. Oh, 116. Cool. So I got that x is 116. Don't be fooled. That's not the answer. Notice how it's not here. In this, it says what's the area. So now I'll have to do length times width. Well, I could say the width is 87. What's the length? The length is, it's not 116, it's not 140, it's those two together, 256. So whatever 256 times 87 is, 22272, all right, there we go. Oh, I need to explain something. My daughter the other day, she was painting her nails with her mommy, and then she looks over at me and she goes, "Daddy," and she goes, "Daddy pink, Daddy blue." So she wanted me to paint my nails, and after I painted these two, she looks at me and she goes, "Daddy silly." So sorry if that's distracting. If you didn't notice them, now you do, sorry. But I will be silly any day of the week for my daughter. All right. So you might notice on the front page, all we needed was the Pythagorean Theorem. It's true. Now we move on, and we're kind of done with Pythagorean Theorem questions. We're going to be changing more into doing trigonometry. So this first question is a great review of the trig basics. It says sine of A, cosine of A, and tangent of A. So here's our angle A, and I'll remind you of our acronym. One way that we write it is like this. SOHCAHTOA. The other way that people will write it is they'll actually write the little fractions in here, which I do think is the better way, but it's just, everyone works a little bit differently. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So when I'm asked for sine of A, well, so here's A. What does opposite mean? Opposite is the one that's not touching it. It's the one that's on the opposite side of the triangle. So this is opposite. The right angle always points to the hypotenuse, so this is the hypotenuse, and the adjacent is the third side that I didn't label. That is personally how I like to label these, but everyone's a little bit different. Key thing is opposite can't actually, like this whole side doesn't touch that dot. But A and H both touch that dot. And out of A and H is already taken by the right angle, and A is the leftover one. So that's an important distinction. A lot of people will mix up those three. So hopefully that kind of clears things up a little bit. So when I see S is O over H, I literally go to sine, and I write O over H. O is 195, H is 197, so it's 195 over 197. Cosine of A over H, 28 over 197. tangent O over A, 195 over 28. So when we know the setups and we know how to set up our triangle, these are easy. Then we get to question number 6. It says, which one of these is equal to 1/2? Well, let me see. What's sine of, oh, pause, Canfield. Remember, anytime you pick up a calculator, if it's not your personal one, somebody might have switched it to radian without telling you. So you want to go over to mode and push the mode button and go down here, right? This is what you want to see. You want to see radian empty and degree highlighted. So then you can clear out of that. So if I type sine 30 degrees, I get 0.5. Wait, it says which one's equal to 1/2? 1/2 is 0.5. So sine of 30 is equal to 1/2. What about cosine of 60? Oh, that's also equal to 1/2. Oh, is this all of them are equal to 1/2? No, it's not. Sine 45 is that. Nope, so it's not that. Then tangent of 30. Oh, nope, not that. It's close, but it's not there. Cosine of 45, 0.7. Nope, not it. And then tangent of 45. Nope, not, okay. So none of those. All right. When you get to pre-calc, you get really, really connected with these. And so having taught pre-calc a bunch of years, I actually have all of these memorized. And there's an easy way that you learn how to do that, but that's for the future. Don't worry about that now. All right, to the nearest tenth, what is BC besides my initials? So we want to know this side x right here. Okay. I know x and 5. All right, so I can't use the Pythagorean Theorem. Because if I could, I would just use that. That's way easier. But I do know 5. Oh, and 5 has a special name, right? 5 is the hypotenuse. So I have the option now. I can pick angle 29 or angle 61. It doesn't matter which one I pick. So angle A or angle B, the 29 or the 61 or the 29, doesn't matter. So I will pick the 29 because that's what I feel like doing. It purely on a whim, it doesn't matter. You could have picked 61. When I pick 29, the names get locked in, right? That's still hypotenuse, but now across from 29 is my opposite, and then X right here is my adjacent. Those are very important. This is gonna be very important in a moment. Had I picked 61, O and A would be switched. O would be over here now, and A would be over here. So it really matters which one we pick. So look at 29, and then I look and see, okay, well, I know 5, so I know the H, and I know that I want to know what X is, because that's what the problem asks for. What I do now is I look up here, and I go, which one of these has H and A in it? S has O and H, so it's not S. C has A and H. Okay, so it's C. And look, T doesn't have the right letters. C is the only one with the right letters. So what I'll do is I'll say cosine of my angle equals A over H, X over 5, right? So this is 3/4 of the problem. The next steps after this are the same every time. The first step is always we multiply by the bottom. It says x divided by 5. So to get rid of divided by 5, we multiply by 5. So 5 times cosine 29. And when we do that, the 5 is canceled. So 5 times cosine 29 equals x. And this is, in this situation, we're done. 5 times cosine 29, and we're done. I got x is 4.37, which is 4.4. So that would be my answer. Don't expect to see multiple choice through this on the test. I want to see your work on things. I want to see your answers. It's okay if it takes me a little bit longer to grade them. All right. So number 8, what is the measure of angle A to the nearest tenth? So if I look at this one, let's just keep on changing colors. It's more fun. It's more fun for me. I mean, I don't know if it's more fun for you. If it's annoying for you, my sincerest apologies. All right. So here's my angle. It wants to know the measure of angle A. Okay. Well, again, we're going to use our SOHCAHTOA. So let me just do this. Get it all in frame. Okay. So I just folded my paper a little bit. I need to figure out what the side names are. Well, I have my right angle right here. That's pointing to my hypotenuse, always. And then that leaves these two. Well, this is my angle, so that tells me then that this is opposite. And then my leftover is my adjacent. Okay, there we go. Since I'm asking for angle A, I have to do it like that. I have no choice about that. So what I can do is, let's see, I don't know H. I do know O and I do know A. Let's see, O and A. Oh, look at that. Tangent, so I can say tangent of my angle is equal to O over A. And remember, when we're trying to find the angle, I have to get rid of tangent and then A will be by itself. And the way we get rid of tangent is we use inverse tangent. Sloppy handwriting, sorry. So now I can say inverse tangent. So that's not tangent. You push the second and then you push tangent. Inverse tangent of 22.9 over 14.1. And I get, it's a 58-degree angle. So let's say 58.4 degrees. Remember, it says 58.3785. Whatever decimal you stop at, yeah, there's a 4 there. Whatever decimal you stop at changes how you round. So if I'm going to stop at this decimal place for some reason, then the 4 tells me, it says, hey, 5, don't do anything, because I'm not big enough to make you do anything. But I chose to stop here. And so the 3 looks to the 7 and says, hey, 7, am I moving up or am I staying? And 7 says, you're moving up. So it's 58.4. It's closer to 58.4 than it's closer to 58.3. That's why we're saying that. So we only round once, we round wherever we stop. And it's just our way of saying, hey, 58.3, 58.4, it's closer to 58.4. All right. Nope, 58.4 degrees. Oh, I already wrote degrees earlier. Okay. There, now I wrote it twice. Aren't you proud of me? We'll put this on my fridge. All right, final page of our review today. We haven't done a ton of word problems, so I just thought I'd put a couple on there. Sometimes we have to draw our diagrams from scratch. Sometimes our teacher feels bad for us and is afraid that we're gonna have trouble reading, and he just draws them for us. All right, let's see. What is the angle of elevation to the nearest 1/10 of a degree to the top of a 45-foot building from 85 feet away? Wait, without all that, I can just, solve for x, okay. Let's see, here's x, here's our right angle, because it says it's a building, so same thing on the next problem. In real life, we do a lot of assumption about things being straight up and down. Okay. So if we're trying to find the angle of elevation, that's going to be this. So let's see, boom, that points over to my opposite. This is my hypotenuse, so this is my adjacent. So I have O and A. All right, we have O and A. So that's tangent. So I can say tangent of x is equal to O over A, 45 over 85. Well, hey, all I gotta do then is inverse tangent, 45 over 85, 27.89. So x is equal to 27.89727. All right, I'm going to round to this decimal place because I feel like it, and because this lets me show something off. So if we're rounding here, then the 9 looks at the 7. It says, 7, what do I do? 7 says, you round up. Oh, okay, well then that means it's going to round up to a 0. And then the 8's going to round up to a 9. So that's what would happen if we rounded to the second decimal place on this. If we rounded to the first place on this, we'd get 27.9. Might seem like not big of a difference. It's not. It's a minor thing that can be important in computer science and stuff like that. But not in our day-to-day. It's not as super important. Oop. Degrees. Degrees, right? We're finding an angle, so we end with a degrees. Whenever we're trying to find an angle, inverse tangent, inverse trig finds angles. So trig to the -1 finds angles. Regular trig finds sides. All right, let's see. The angle of elevation from a viewer to the top of a flagpole is 50 degrees. If the viewer is 20 feet away and the viewer's eyes are 5 feet from the ground, how high is the pole to the nearest tenth of a foot? So I drew this up for you, and we've got a 50-degree angle here, and then we know that this vision line right here, this is 20 feet. It's a right angle because it's straight up and down, and that's parallel to the ground. This is called the angle of elevation from the ground up to wherever you're looking. And then we want to know the height of the whole telephone pole, or flagpole. Here's the problem. We don't know this piece. We do know this piece, though. This piece is 5. And we're not dealing with a triangle with the whole thing. We're only dealing with the triangle with the top piece. So let's just use the top piece. I'll call this A, since I already called that X. Maybe I should have called that X, but it's too late now. I called that X. Okay. So I'm looking at my angle. I have A and I have 20. Oh, well, so I know that's my opposite. This is my adjacent. That's my hypotenuse. So I have opposite over adjacent. I have tangent. I can say tangent of 50 is equal to A over 20. So my next step, multiply both sides by 20. So 20 tangent 50 is equal to A. 20 tangent times tangent of 50. So you can do that. You can do 20 times tangent of 50. So I got 23.835. So A is 23.835 feet. And that's this piece right here. So if I want to find the whole thing, take that, it's 5 more. And that'll give us the whole telephone pole, right? So just add 5 onto that. The whole telephone pole, keep calling it telephone pole. The whole flagpole is 28. And 835, I'm gonna round to the first decimal place. If I do that, 8 says, hey 3, what do I do? 3 says, now you just chill. I'm not, because if it's not 5 or bigger, it just chills. So this is 28.8 feet. And yeah. Hope that was helpful. Good luck on your test. Bye.